Hey everybody, this is Larry. This is day 21 of the October Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. Asteroid collusion. You're given an array of asteroids, weapon, absolute size and a direction, meaning left, positive going right, negative going wrong, and move at the same speed. Okay. If two, is it just, where's the location? The smaller one was exploded. They both exploded. Okay. So there's a direction and a size, but no location. I guess this is the location, like the index. Okay. Let's see. So the 10 goes to the right, kills the 5. Ba-bam. 8 and 8 exposed together. Negative 5 destroys the 2, and then the 10 and the 5. Right. Okay. So n is in this case okay. I mean, I think I get the concept. I'm just reading the problem to understand it. I'm doing this live, so the explanation might come a little bit, all over the place. But let me know if you're learning this way, because sometimes for me, seeing the thought process is more interesting than just seeing the solution. You could find that anywhere. Okay. So my first thought is that 10 is to n is equal to 10 to the 4th. So that means that any n squared stuff, which would be the naive way, I believe, it would be too slow, right? That's the size. I don't think that matters, and it doesn't have 0, which is good. I think in this case we have these events, and we just keep on going. I think I have 2 dots. That I could 2 approaches that I have to figure out which one I want to go. One is maybe some sort of greedy, where we take the biggest asteroid and then keep on destroying stuff, and then maybe do some kind of math that way. Because I imagine there's some I think there's a prop. This is just from gut and intuition, but there's some kind of feeling that there's just some stuff that would just eventually the things that would get crushed is in the middle, right? Because if it's on the side, then either they are behind either bigger asteroids, or they're going out anyway, right? So there's some intuition there. The way that is brute force, but with a speed up is noting that. So the greedy part, the thing with the greedy is that you have to prove it, right? And I'm not quite sure, even though I have some intuition about it. Sometimes you're right, sometimes you're wrong, given when you have strong intuition about it. And this one, I don't feel like I have a strong intuition. This one, like I said, is just simulation, but with a speed up so that it's not n squared. And we could do this in n log n with something like a heap. And the thing to notice is that things only happen when two adjacent things have opposite signs, right? So in that case, and more particularly, it's when a positive number is followed by a negative number. That's the only time they collide. Because if you have the opposite sign but going the other direction, then they don't collide because they're literally moving apart, right? So those are the events and the indexes that we kind of could keep track of. And then the invariant there, and I talk about invariant a lot, the invariant is that after collusion, the state of the array is mostly the same, other than that now there are one fewer piece, right? So then now you could kind of look at what the next cell is. Like, for example, well, in this case, it's not as demonstrative, but let's say you have, let's say your array is this, and then you have I don't know, negative 8, negative 8, negative 10, right? After this collusion, we process it, we put that 10 back in, and then now we look at the 10 because that's the only thing that changed about the array, and then we could look at, oh, did it change with the negative 8? Well, yeah, there's still an ongoing, there's still an impending collusion, so let's process that, right? So that's kind of the idea that I would think about. And I don't think order matters because they only kind of merge each other, right? There's no way if you have 2 collusions in different places, they will still how do you say this? they will still like, happen independently of each other, right? So then now we think about implementation, right? I think, like I said, if you do a heap to kind of keep track of the indexes, you can do that in log n time. And if you do it smartly, you could do it n log n times. There's also, from that, maybe you could do some stuff with a binary index tree to kind of keep track of how many things we move, so that you could figure out the real index of the numbers that you're trying to process and so forth. I'm going to have to think about the implementation from this point. And the implementation may be a little bit tricky in that now, if we boil that down to that step, now it's bookkeeping, right? And what do I mean by bookkeeping? So in terms of implementation and bookkeeping, it's just keeping track of a lot of things, so that, or enough things, so that the next state, you have everything you need to remove the next item, right? And I think I can do that. So I'm going to do it that way. And we'll go through it slowly, maybe a little bit fast, but we'll go through it. Let me know what you think. We're a couple of minutes into this video. Yeah, but I think what I'm going to do is just keep track of, for each node, we're going to keep track of the left and the right. And the reason why we do that is that, let's say we have this, right? And we delete the -8. If we delete the -8, then we only have to, like I said, it only changes one thing, right? Which is almost like a linked list, kind of, where the next item of 10 will be a negative, you just kind of put the next pointer of 10 to -10 and -10 previous pointer to 10, right? So that kind of like, I'm not going to actually implement this using a linked list, but that's the idea of how I will implement it. And from that, because you're only doing all one operations, it should be fast enough. But that said, it is tricky to get right sometimes, so we have to be careful. Okay, so let's create, let's create an array. And we want to create something like, so the left of the first element would be, let's just say -1 for our bounds, -1 to n-2, because the last element is n-1, right? So that's basically what I'm thinking. So let's say n is linked for asteroids. So then it's just x for x in range from -1 to n-2 inclusive. So +1, so n+1, something like that, right? And then the right is similar. Actually, I think I should have done it like the dumber way, which is this, right? From 0 to n. I think I was trying to be too clever, maybe. So n, and then for y is just for x is in range n as well, right? Okay. And then now we will create events using a heap. And wait, I said heap because I don't know, that's always the thing that I always think about, but I actually might be wrong here. Actually, like I said, the order doesn't matter, because they always only, like, there's a property about they only colliding each other, right? So like you can, like, there's no way for you to skip over to have like a later rock collide, right? So actually the order doesn't matter. So we can actually just use a straight up queue, and you don't need a priority queue because there's nothing to prioritize. In my mind, in general, I always consider priority queue because it's log n, and it's usually fast enough for whatever you need to do. But in this case, actually, queue makes sense now that I step a little bit into it. And in Python, the implementation is called deck, to be able to remove from the front, because you can always remove from the back as well. But okay, so then now we go through the array, which is for index in range of n, if, and again we said that if a positive number is followed by a negative number. Okay. Positive, a collision happens when it's a positive number followed by a negative number, right? Let's put it here. So if asteroids of index is greater than 0, and there's no 0, right? And asteroids of index +1 is less than 0, then then this is an event and we want to put it in somewhere. And of course we have to check that this is, you don't go off the board. So let's just do n-1. Okay, if this is the case, then q.append, let's just, for lazy sake, index +1 for the 2 indexes. And this is how we kick off. This is how we're probably going to end. Yeah, I guess we need, I'm just thinking about the output format right now and how to kind of do it. There are a couple of ways we can kind of take care of it. I'm just going to have an alive Boolean thing, which is true for times n. Yeah, and then now we're going to check while length of q is greater than 0, meaning if there's a collusion to process, we check. And collusion always removes one item, I believe, and sometimes 2, but at least one item, right? So okay, so if absolute of s2 left index is equal to q dot top, or this, and right index is the other one, right? And then q dot pop left, just doing this now because sometimes I forget to type it and it gets awkward. But left index, is greater than asteroids of right index, then in this case, right index gets destroyed. So what happens when the right index gets destroyed, right? And we're doing it step by step. The right index gets destroyed, then well, first of all, let's set it as dead. So alive of right index is equal to false, sad face. And then now, now the left index, the right of the left index is equal to the right of the right index, right? Does that kind of make sense? This is kind of like linked list, so kind of keep, so that's, yeah. So that's basically the idea. If you need help visualizing this, just draw the pointers on the left index and the right index, and then the right goes to the next one, right? That's how I come up with the code, because this is not something that I have patterns for example, right? And then now we want the right of the right. So we want left of, so this is some assumption is that they're next to each other, right? So what is the right of the right? Well, left of the right index is equal to left index, or yeah, left index is right, because this is also left of right index, in case you're wondering. It's just that left index, I guess, is clearer. Yeah. Okay, I think this is right, and yeah. And then I'm trying to think whether I should do that here, but right in the beginning, because I'm not so sure about this, I'm going to try to do it as naive as possible, and then I'll maybe clean up the code a little bit once I take a look at it afterwards, and after it gets fixed, right? So so then that means that now we have to see if there's a new collusion. That's basically what I want to do. So if asteroids of left index is greater than 0, and asteroids of the right of the left index, now remember that this is updated, is less than 0, we want to append this. So then now we append the left index and then the right of left index. And now we do the same thing, but for the other case. And just like linked list problems, I have to talk it out every time, because otherwise I'm not, it doesn't happen in life enough that I get practice that I, be able to visualize it very quickly. But yeah, so the left index got destroyed, alive of left index is equal to false. Also, we have to do some bound checking. I think that's what I forgot. I think none of these bound matters except for this one because we're looking at the array, right? So so right of left index is less than n and this stuff. Because in this case the right would be, you know, n plus, or actually it should be n exactly. But yeah, so which is this, you know. Okay, so we said the alive of the left index is false, sad, and then now what happens, right? So the right left is equal to the left. Oh, sorry, the left of the right index is equal to the left of the left index, and then the left of the I might have some additional if checks actually, but if, what is this again? So you fix the right, the left, no, the right of, so left gets destroyed, then the left of, no, the right of the left goes to the right. Okay. It's a mouthful. Now we do that if asteroid thing again. I think I need to check something. I need to check that, for example, this is not -1 because this could be -1. Yeah. Dex is greater than 0. We do this, and if left of, no, this is okay. I mean, this could be out of bounds, right? We could set this to be out of bounds and that's okay. And left index is clearly in bounds. We have to fix this as well. So actually, if right of right index is less than n, right? Okay. So if this is what I wanted, right? But this thing died. So we have to look at the new left index. So left of this, and we have to check that left of left index is greater or equal to 0. I could probably combine these actually. Just like here, I could have combined them as well. So let's do that actually. Let's remove this and now indent it so that is part of this. Okay. And same thing here. We could get rid of this if we just do this, and asteroids of right index is less than 0. I forgot to check that is greater than 0. If this is the case, we append the queue again. Left of left index, right of, no, just right index, right? And then otherwise, the other case is if they both get destroyed, if they're the same, right? This is just a lot of, as you can see, this is tiring, but you know, it's okay. So both of them get destroyed. So now the tricky thing is, okay, so left of, so let's say with the left of that set the next right. Okay, so if left of left index is greater than or equal to 0, right of left index is equal to right of right index. And this is okay if this goes out of bounds, because that's an invariant that we're okay with. Same thing, if this is less than n, then left of oh man, right, left of right index is equal to left of left index, right? So the left of the right to right will be left. Okay, so again, maybe I should have done this with linked list. Maybe that would have been a lot easier, but it's a little bit late now, because then you could just at least easier to understand or easier to explain, because I think this is actually straightforward for me, minus maybe silly mistakes. But then now if they both collide, then then now we check again. In this case, we do have to write it again because we need both of them to be true for us to contemplate a collusion. And asteroids of left index. Maybe there's a easier way, I don't know, but I'm in too deep. Right of right index is less than 0. Then we put in the queue. Left of left index, right of right index. And I definitely recommend y'all draw it out. I mean, I would do more visualizations, but I think this, if you use a linked list visualization, this is pretty straightforward. So to understand why, you know, all these statements are the way they are. If not, let me know in the comments and maybe we could figure something out. But that's why I want to, you know, like, let's say that your prerequisite is knowing linked lists, and there's a lot of linked list problems on this thing. So yeah. Yeah. And then now we just keep track of what's alive, and then we return the results. Results is equal to yeah, let's just, we could actually return this as for comprehension, where x in what is this array called? Oh, asteroids. As in enumerate for index x in enumerate asteroids if alive of index, right? Okay, let's see how it goes. We're gonna have to put in more tests and probably a little bit more testing because I think the example testing are not very detailed. And again, even though this was a straightforward problem to explain, it took me about, this is 20 minutes in, so a lot of bookkeeping, as I was saying in the beginning, and a lot of prone for errors. So maybe I could do a little bit better on optimizing for code speed. But yeah, so that looks good. Now I'm just going to write an empty array, one element, maybe just like, I don't know, something like that, so that they all collide. And see, ooh, I got 0. Oh, okay, so 0 is not in the input. Sometimes they still trick you, so I always try. I don't know. I just didn't look into it. Oh, 2 elements. Okay, fine. I didn't read the here as well. Okay, so that looks good-ish. Let's give it a submit. Yay! Okay, so let's go over the complexity again. I know there's a lot of while loops. There's a lot of queues. So the space, we'll do the space first because it's easier. There's a queue, there's a left, and there's a right, and there's a live. So this is going to be linear space, right? So what is the time, right? Well, this is obviously linear, but how do you prove that this is linear, right? Well, as we said before, every time this loop runs, we take 2 elements from the original array, and then we get 1 left. At most, I mean, sometimes you get 0 left. So that means that if this array starts with n elements, if this array starts with n elements, then after 1 iteration with a queue, you have n minus 1 elements, right? And then n minus 2, and then so forth. So at the end, this loop is going to be O of n times. So yeah, and we pretty much do everything here. You could kind of take a deeper look. It's going to be O of 1. So you have a loop that will execute O of n times, and then for each loop it does O of 1 work. So this is linear time. So linear time, linear space. Let me know what you think about this problem. Like I said, it was a lot of bookkeeping, a lot of tracking, but you know, you can do better than that, I don't think, because that's the lower bound. But I'm going to take a look at the hint to see if I know anything. Say a row stable. What happens when a new asteroid is added to the right? Oh, so I guess you could do it with stack. I guess that's the way that they would phrase it. I guess that would actually, I guess the way that I did it is actually really complicated now, because with a stack, you probably could do it with like 10 lines of code or something. Well, mistakes were made. But Well, but that also shows to that also shows that there are multiple ways to do this problem. Let me know how you did it. Let me know if you got the stack one. Wow, because in the stack one, I would have probably gotten this in like 4 minutes or so. But oh well, sometimes it is the way it is. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will see y'all tomorrow. Bye bye.